Hello everyone, we are Group DG08. Today we will present our group project, Eco Shelter, the design and implementation of suitable low-cost house unit using adapted underground mining. First we, our team, the first member is Jason Suryachi, Senaratne, Senaratne, Senanandya, and Sajeev. First, we are going to the introduction. This project is about global population growth is putting huge pressure of housing here, especially in cities. Land is scarce, overcrowded, and expensive. Meanwhile, many underground mines are abandoned after mineral extraction. They remain empty, often needing costly depletion. Our solution: convert these minds into alternative living spaces. We call it the pit-to-ports concept, safe, affordable, and eco-friendly. We go to the next slide, the problem statement. Let's look at the problem very clearly. Rapid population growth increases housing demand. Urban land is scarce and expensive. Surface construction costs are rising. At that time, many underground mines are left abandoned, reflecting Thames' expensive and resource inefficient, and digging new space damage and more lands is very important for our topic. So we have large unused underground voids while we need to afford housing. That's the gap we want to fill. Let's move to the next slide. Proposed solution site selection. It's about our one solution: reduce abandoned mines without refilling them. We have selected the Meetiyagoda moonstone mine, particularly abandoned by the extending tunnel and shaft at depths of 10 to 40 meters. Their geology is suitable for reuse, making it ideal for underground housing development. The next slide. The objectives. Our objectives are very clear. Ensure basic needs: air, water, shelter, food, underground. The second, design ventilation, lighting, power, and sanitation system. The third, evaluate structure, safety, and stability. The fourth, reduce costs compared to mine repair. The fifth, create a scalable model for other mines. We go to the next slide. Pit-to-port concept design. We must know about pit-to-port concept for the design. The concept uses model underground ports, comfortable, lightweight units arranged in multiple levels. We adaptively reduce executes mine voids, minimizing structure changes. Integrate utility system and a community layout make it available and organized. The next one, design purpose. No content, skip or verify post. This slide. Uh, the methodology system. Our methodology covers three areas. First, site analysis. Second, material selection. The third one is structural design safety. First, we see about site analysis. The tunnel layout, rock stability, water leakage risk, and accessibility. The second, we see about material selections. lightweight steel frames, stable dirt blocks, and waterproof gas-resistant materials. Then we go structural design safety, requiring stable struts, retaining supports, protective living linings, and continuous monitoring. Then we go to the engineering systems. So we have to plan 6 engineering systems in this project. The first one is ventilation, air, shaft, and mechanisms. The second is lighting, power, water, sanitizing, transportation, safety. We must about transportation in this particular. This is electric cars and lift system. The safety is drainage, truck boards, and structural monitoring. The water and sanitary pipes, wastewater, and treatments. Let's we move to the next slide. Conception sketch. Here's a sketch of a future underground mine community could locate. Then engineering cost and comparisons. Let's compare condition mine refilling with our pit to pole system. Material usage. Refilling means huge volumes of solid soil and concrete. We are reuse existing voids, so near zero fill material. Transport cost. Refilling requires continuous transport over many. Land resource. Refilling often requires speed. Environmental impacts. Refilling both emissions and land distributions. Our approach is very low impact, time and cost. Refilling slow and very expensive. Ours is faster and low to moderate cost. So the red is bad, green is very good, and we are clearly the green option. Then we go to the key outcomes. But to be achieved, reduce of abundant mines is less effective to service construction, low costs, reduce environmental damage, and most importantly, a safe, affordable housing solution through the pit-to-pole system. This is a sustainable way for recycling industry space for future needs. Finally, we go to the conclusions. To conclude, one underground mines carry real potential for future housing. The second conclusion is our project offers an innovation reduce of unused imperfections. It support merge mining engineering with sustainable housing, reduce mine voids, avails for unnecessary excavation and recommendations. This is the low-cost, environmentally responsible housing alternative for growing cities. Thank you. We are happy to take any questions. Goodbye.